So you chose to get some help with absolute value. Well done. Kudos to you. So without further ado, I want to go through the prerequisite station 1 with absolute value. So let's flip the camera over and let's take a look at this stuff. Hopefully you remember some of it. It's just kind of fine tuning and making sure what you think is happening is actually what's happening. I'm going to go ahead and start. I'm going to treat these kind of like parentheses. We don't always treat them like parentheses, but in this case, I'm just going to do the inside first. -2 plus 6 is 4. Next, I'm going to take the absolute value of 4, which is just 4. Then the opposite of that, the -4, minus another 4. This first one should be -8. Awesome. Moving on. Next one. It says whatever's inside here, I'm going to take the absolute value of whatever's inside here, and it's going to equal 6, which means whatever's inside of here, 2x, could equal 6, or the opposite of what's inside of here could also equal 6. Because whatever's inside here, the opposite of that, I'm going to end up taking the absolute value, and that would get rid of that negative sign. But we need to account for that. I'm going to focus this thing real quick. I don't like how it's focused. It's a little bit better, maybe not. But the opposite of what's inside here, I'm going to end up getting rid of that negative. So I'm going to solve each of these equations, figure out what x can be. I'll divide by 2. I'll get x equals 3. I'm going to divide the negative over to make this a -6. And then I'm going to divide by 2 and also get x equals -3. Now, if you're doing that, wondering, Mr. Roberts, why are you doing it like that? That is not how I learned it. We just did 2x equals 6 and 2x equals -6 and got the right answer. You're fine with that for now, but keep in mind what I was talking about with whatever's inside of here can equal 6, or the opposite of whatever's inside of here can equal 6 as well, because that's going to come into play later on down the line. So let's look at C real quick. We can think of absolute value as distance between two things. The distance between my number and 7, absolute value, is 6. So now I come down here, I want to write an equation for the same sort of thing. The distance between my number and -9, so I'm subtracting my number and -9. That distance, absolute value, has to equal 4. So then we're going to do pretty much the similar thing to what we did on part B. Minus a minus becomes plus, so I'm going to get the absolute value of x plus 9 equals 4. That's going to give me two equations. Whatever's inside of those parentheses could equal 4, or the opposite of whatever's inside of there could also equal 4. Okay? There are also those equations. I'll do 4, I'll take away 9 from both sides, and I'll get -5. Over on the other side, I would divide the -1 over to the other side. It's looking like it's a useless step, like why not just do 4 and -4, but stick with me, you'll see it in the end. Subtract 9 on that one as well, and I'll get -13. So my two answers for this one are -5 and -13. Part D, I'm going to subtract the 2. That gets rid of that. That would give me -9. Then I'm going to divide both sides by -1, and that would give me +9. So I'm going to have 1/2 x minus 9, absolute value, will equal +9. Now we solve it like we did before. Whatever's inside of this, absolute value, could equal 9, or the opposite of whatever's inside of this could also equal 9. Easy enough, we'll solve those. I'll add 9, I'll multiply both sides by 2, so add 9, 18. Multiply both sides by 2, multiply both sides by 2. Those will cancel. I'm left with x equals 36. One of my answers. Over on the other side, I'll divide by a -1 to make that a -9. I'll then add 9. That'll give me 0. And I'll multiply by 2 again, and I'll still get 0. So my two answers for this one are 36 and 0. I can check my answers too. I can go back and plug these in and make sure they work. If I plug in a 0 here, half of 0 is 0. 0 minus 9 is -9. The absolute value of -9 is 9. And then we have 2 minus 9. 2 minus 9 is -7. So that one works. You can do the same thing with 36. And then finally the last one, a little inequality, but if you've been sticking to the plan here with what I was explaining, we're going to treat it kind of the same way we treated the last one. So this is saying the distance between my number, the humidity outside, and 45, the distance between those needs to be less than 15, needs to be within 15 units of humidity there. So I'm going to do it the same way. I'm going to solve it the same way I was solving before. I can say whatever's inside of here, h minus 45, needs to be less than or equal to 15. Or the opposite of whatever's inside of here also needs to be less than or equal to 15. And now hopefully the gears are turning a little bit. Well, I'll solve this one. That's not a big deal. I'll add 45 to both sides and I'll get 60. H has to be less than 60. The humidity needs to be less than 60. Or, now on this one, I need to divide the negative over. And when we divide by a negative, this is when the inequality symbol is going to change. And that's why I kind of had us running through that, doing it a different way, so we can kind of see the why behind this. Why does the Pac-Man flip? I remember my teacher told me inequality switches on this, but this is why. We're doing the opposite of this thing. We're going to divide by a -1 and get h minus 45 needs to be greater than or equal to -15. Okay, and then I'll solve that thing. I'll add the 45 over just like before, and I'll get that the humidity needs to be greater than or equal to 30. So what is the highest and lowest relative humidity we can be on this device? It needs to be less than 60, but greater than 30. So the minimum is 30, the maximum is 60, and we're dancing. Absolute value. Good job tuning in. Peace.